Hello, chemistry students. I thought it would be a good idea just to go through a practice problem dealing with how to interpret a phase diagram. So this is the worksheet that I gave you last Friday, so go ahead and please take that out. And we are going to go over the first side together, and so what I want you guys then to do is to then work on the reverse side. And so this will count as a grade, so make sure that you do in fact do this. Just to review, remember that we have different phase changes that occur based upon either the change in pressure or the change in temperature. And the way that we can graph this is by using what is referred to as a phase diagram. And so the picture here shows you what a generic phase diagram looks like. So we have a couple letters, and we have, again, remember, we have our pressure here on the vertical axis. It increases as we go up, and the temperature, which is in degrees Celsius, is going toward the right. And so we're going to first of all identify the different features in the diagram above. And so, for example, part A is looking for the solid phase. And so when you think about solids, think about ice, for example. What do we know about ice? Ice is cold, and so compared to other things. And so we would expect then the solid is going to be on the left side of the phase diagram because that's where the temperature would be coolest. And so if we look at our phase diagram, we can identify that in fact A is the solid phase. So this region right here is our solid phase. And so we put an A, capital A then for part A. B, the liquid phase, is therefore when we heat up a solid, we start to use the heat to disrupt the intermolecular forces. So again, if you think about ice, we're breaking the hydrogen bonds, we're allowing them to get a little bit looser. And so by doing that, we're going to see that we're going to need to increase the temperature. And so if we look, we will see that C here is the liquid phase. And so again, for part B, go ahead and put a capital C in for that. Now we have to identify the gas phase. And so remember, the gas phase would be where the molecules are the most excited. They're going to be bouncing off each other, bouncing off the containers of the wall of the container that holds it. And so we can then therefore see that if we look at choice B, this therefore represents the gas phase. And so for part C down here, put a capital B. All right, next we need to look for the triple point. And so the triple point, as you remember, is where we have both the solid and liquid along with the gas. And so all three phases have to exist at the same time. If we look at our graph, we've already identified that this is our solid, this is our liquid, this is our gas, and so the point where they're going to intersect is at point D. And so for this one, for D, the triple point, then you're going to also put down lowercase d. The critical point, as we talked about yesterday, deals with the pressure at which you can no longer cause the gas to go into a liquid phase. And so if we look, we're going to see that point E is therefore the critical point. So go ahead then on your sheet, put down E for E. And so that is how we're going to identify this. So again, the solid phase is A, the liquid phase is C, the gas phase is B, the triple point, where all three states of matter exist at the same time, is point D, and the critical point is E. And so those are the answers for number 1. All right. The next couple questions, we're going to go ahead and answer those as well. And so the second question asks, what is the substance's normal melting point at 1 atmosphere of pressure? So whenever you see the word normal, in this case, it's referring to a pressure of 1 atmosphere. And so that is what we're normally subjected to. And so what we need to do is remember that melting occurs when you go from the solid phase to the liquid phase. And so we're looking now for the specific temperature. And so remember that A was our solid phase, C is our liquid phase, and so we need to identify the temperature where this is going to occur. And so if we look, we're up here at 1 atmosphere. So we're in a solid phase right now. It's still solid, still solid, still solid, still solid. And then once we go past this point, we're going to be then entering the liquid phase. And so we can therefore take this point, drop it down here, and therefore we're going to see that the temperature where it melts is at 60 degrees Celsius. So make sure that you put not only the number, but also the unit. So this is 60 degrees Celsius. And so this is the point where we go from the solid phase to the liquid phase. And so let's now turn our attention to problem number 3. Problem 3 is going to now ask, what is the substance's normal boiling point at 1 atmosphere? So it's the same idea. Remember again that in order for something to boil, we're going from the liquid phase to the gas phase. And so we're going to see then, C is our liquid, B is our gas. We're still up here at 1 atmosphere. And so notice that we're liquid here. We're still liquid, 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 liquid. And then once we cross over here, now we're in the gas phase. And so it's at this point when we see the phase change. We drop down here, and we're going to see that we're going to be at 100 degrees Celsius is the normal boiling point. So 100 degrees Celsius, therefore, is the answer for number 3. All right, number 4. Above what temperature is it impossible to liquefy the substance no matter what the pressure? And so what this question is basically asking for is the critical point. And so the critical point, again, if you remember, is point E up here on the phase diagram. We drop down here, and we're going to see that that temperature is at 110 degrees Celsius. And so the answer for number 4 is 110 degrees Celsius. All right. Next, we want to talk about, for 5, at what temperature and pressure do all 3 phases coexist? And so let's go back up here to our graph. And so remember, where they exist is going to be what we refer to as the triple point. And so again, that would be point D. And so we have to give both the pressure and the temperature in order for this to be correct. And so notice the triple point is going to be at 0.5 atmosphere and at 45 degrees Celsius. And so we have 0.5 atmosphere and 45 degrees Celsius. And so both of those numbers are needed along with their units to answer that question. All right. Next, we're going to now look to see what are the different phase changes as we go along. And so this is a good review from yesterday. So for example, if we're going from A to B, so we can come up here to our graph, A to B, we're going to see, remember that A was our solid, B was our gas, and so if we're going from A to B, we're going from a solid to a gas without first going through the liquid, and so that would be called sublimation. And so that will be the first answer for that one. So sublimation first. Part B is looking for B to A, and so what we can do is come back up here, and so B to A, notice what we're going from the gas phase to the solid phase without first going through the liquid phase, and so the opposite of sublimation is deposition, and so that is the answer then for that part. So the second part for that question is deposition. Part C, we're looking now for the phase change that occurs between A to C. We come back up to our phase diagram, and so we're going to see again that we have our solid going to our liquid, and so solid to liquid means that we are undergoing melting. And so for part C, you can write down melting. All right, let's look now at part D. Part D is going from C to A, so C to A. We're going from the liquid back to the solid, and so the opposite of melting would be freezing. And so part D, you can put down freezing. All right. Part E, we're going from B to C. And so if we look up here, notice that we're going from the gas phase up to the liquid phase. And so we refer to this as condensation. And so that's going to be condensation. Finally, if we look down here, we're going to be looking for the transition between C and B. We come back at our phase diagram. We're starting with a liquid. We're going to go to a gas. And so the phase change that occurs between a liquid and a gas is known as vaporization. And so that would be the answer for that. And so those are the answers then for the front half of the sheet. And so what I'd like you guys to do then is to go ahead and do the back side of the sheet. Again, it'll give another phase diagram. It'll ask a few questions based upon that. And so make sure that you do that, and so it'll count as a grade. And so I hope that this was helpful, and I will talk with you guys again soon. Thank you.